In this video, I want to talk about how to parameterize a function. Particularly, I want to find parametric equations for f of x equals the square root of x minus 2. Well, I know what that graph looks like, right? It's the graph of a square root function shifted to the right 2 units. Not too hard to just plot a few points. So if x is 2, I get out of 0. If x is 3, I get out of 1. And finally, if x is 6, I'll get out a 2. And so I know I get the square root function. Well, that's a plane curve. I should be able to find parametric equations for it. So I'm really looking for a set of parametric equations that will graph that square root function. So if x equals something and a y equals something on the variable t. Well, if I just think about what functions do, it's exactly what I was doing here, right? I picked a 6, and then I used the function to evaluate. So when x is 6, y is 2. And that would work for any value I ever put in, right? If I just pick another nice one, right? 11, right? And the square root of 11 minus 2, all right, I get it, and that's a 3. But in doing this, I kind of see I'm picking an x and plugging it in the function. So I could just pick an x, like t, and then it would be a square root of t minus 2. And oh, there are my parametric equations. You let x equal t, and then y is, well, what the function said to do. Because every time you pick an x, you find a y using this formula. And I need to let t be any real number it wants to be to get the whole. That's not true. That was going to be a real dumb thing to say. I should edit that out of the video, but I'm going to let it live because it's okay to make mistakes as long as you're thinking while you're doing them. So if I look at this square root function just based on the way I graphed it, I can see the domain. X has to be greater than or equal to 2. Well, if x equals t, that means t has to be greater than or equal to 2. So I should probably let t be greater than or equal to 2. That 2 is less than or equal to t is less than infinity. That's the domain for my parameter. So there are my parametric equations for a function. Given a function y equals f of x, we can always parameterize it by letting x equal t and y equals f of t. Because that's what functions do. You pick an x and the function finds the y value. To find the parameter interval, right, the interval where t lives, we have to think about the domain of the function. And I almost wasn't thinking enough to catch that, but we got it. That's it for now.